To first understand what a spin is, we first have to understand what a stall is. A stall is best described by a wing that has quit producing lift. Lift can best be described using Bernoulli's principle. Bernoulli's principle states that when air travels over an airfoil, such as the one that we've got pictured here, air tends to meet up with an air of the same place, so a buddy, so to speak. So this guy on the bottom obviously goes straight across because there's nothing in the way. This guy on top has to travel over the wing, producing a low pressure area. The one on the bottom is a high pressure area. Now, a high pressure likes to go to low pressure to equal it out. And the only way to do that is to go through this wing, in turn producing lift. Now, in a stalled situation, these molecules can do a number of things. And the one that we're going to discuss also helps to cause a spin. Now, the wing, what ends up happening, this guy on the bottom does his own thing, goes straight across, waits for his buddy over here. Now, when an airplane's going too slow, the air molecule doesn't have enough speed to get over the top. So it comes up and it falls short, running into the airfoil. It'll stop right here and it'll end up crashing into the wing, making the airplane quit flying, fall out of the air. It sounds bad, but it's not that bad. Now, in our case, we have to understand what happens when you're in a turn or how an airplane gets uncoordinated. Now, here's our airplane. What ends up happening in a steep turn, a turn that's over 45 degrees, the back end tends to fall into the turn and the nose tends to fall out of the turn. In order to counteract this in a normal, stabilized, and coordinated turn, we use the vertical stabilizer right here to bring the nose back in and bring the tail back out. Now, in order to spin an airplane, we not only have to have it uncoordinated, so the vertical stabilizer does nothing, and we also have to be going slow enough that the air over the airfoil cannot produce lift. Now, what ends up happening, this inside wing most likely is the one that's going slower, so we'll count that we're turning left in this case. So the inside wing will be moving slower, so this means that the outside wing will be moving faster, so this one will end up going like this, coming out, but when you have the other side going slower, it'll give the appearance of moving backwards. Now what happens is this wing comes over, the back wing comes back, producing a spin. And the spin can last as long as the pilot would allow it, or until they end up hitting the ground.